This conference will now be recorded.
Hello, good morning everyone. Can you hear me? Can you see my screen?
Yes, yeah. Good morning, Rohan.
Morning.
Good morning, Ron.
Good morning. Okay, all right. So I think we were at POSC and we were discussing inbound POSC, which did not work, and we were not able to. I think what was the error? Oh yeah, the goods movement bin was not determined. Okay, yes, yes. So in inbound, we were supposed to do unloading, deconsolidation, LOSC movement to 80 IA, I1, and then we were supposed to do the put away into final bin. So this was our POSC complex put away process, and we defined staging area as rule based with uh, deconsolidation area also a rule based. There were options to put the intermediate areas as through as default or fixed, but we went with rule based. Inbound POC is assigned to it's a storage process with number of steps. They are assigned to the process type, and the intermediate area for the LOSC step is maintained in the LOSC configuration. Then we discussed about several other settings whenever we use storage control. The work center requires some additional settings like having the um, um, bin assigned, the step, the right step should be maintained in the config. Then in case of deconsolidation, the deconsolidation station should be determined. We have done all this configuration, and there was I think one setting which we missed, because of which we were getting that error. So I've just maintained it, and then I did check the issue was the issue was not appearing then. So let me take you through the data again. Think this is not my user ID. Just give me a minute. Let me use the right ID. Okay. So I think the setting that we maintain here, we maintain one important checkbox. That was the reason. we were not able to get the right bin. So I'll just explain you the importance of that checkbox. So here we did not maintain the door. Okay, we just maintained the staging area, but we did not give a default door. So since we did not give a default door, if you see the delivery which we were using, so for example, we were using this delivery. If you look at this delivery, uh, it did not have any door here. That's why, when there is no door, so system assumes that you're not going to load it onto a door. So you're going to, directly finish at staging. So we need to give a default door for that particular delivery. So I tried for another delivery where I gave a door and this bin then did not appear. So for storage control, we either need this bin or this bin. So since we did not have door, both the bins were appearing and that was creating a conflict. So the reason for this error was the door bin was not door was not assigned. Default doors to the staging area was not assigned. Okay. So so now let's create a new delivery and test the process. I will complete this and then I'll take any questions, for storage control. Since we are in middle of this testing, let us finish it. Okay, so we said there are two parts which are packed together. Okay, so here we said we'll pack it into carton and then we'll split them later in the deconsolidation area. So I'll do the packing again. Let's say the vendor EDI sent us a message where both these items were packed into carton, big carton. And now let me save this. Let's go to the inbound delivery now in EWM. Okay, so now you can see here the delivery is there and here the door is there, so the goods movement bin is coming blank, or it's a door bin but not the same staging bin. Okay, so this is a default door bin. We can also change it, if we don't want to receive it into door 2, let's say door 1 is vacant, we can receive it onto door 1. Okay, so that is not a problem, it's just a proposed, and when I receive it into door 1, this will get updated automatically. So it's not a hard determination. Okay, so now this is inbound, so we need to create a truck against which this delivery is coming. So I'll create a TO. This time the TU will be inbound. Paste the inbound delivery. Assign to the TU to the truck. And let's save it. Okay, so here you can see the door is not assigned, but here you can see the delivery has proposal of door 2. So let us now go and start the process. Let us say the truck came to our warehouse, it's at the yard, and we'll say arrival plus save. Okay, so now we need to do the exact reversal steps. We have to unload first. Then I'll go here, yard movements. I will move it to the door. Let's say I don't move it to door 2. I find door 3 is vacant. So I'll create enter door 3. Yard door bin will be determined. I'll say create plus save task for TU and confirm the task as well. So the TU now is in the yard door bin. Okay, so the next step would be to check the delivery, whether the door has been updated in the delivery or not. So you can see now the door 3 is updated, and since we did the yard movement, the goods movement bin has disappeared. Okay, so now it has updated the delivery with door 3. Now this TU is going to wait till we unload the pallets from here. So you can see the HU is assigned because it's part of the delivery, and it has the 2 products. Okay, we just kept it very simple. Now it's time to unload. So in the final setup, there is one step still pending in a complete put away process, that is PPF, which we'll discuss next week. The step is, as soon as we do the I'll take the stock to the door, the status changes to registered in yard, and system automatically creates a task for unloading. So here, since we haven't done that setting, I'm going to create the unloading task manually. Okay, so I'm going to create a task, and you can see now the task is from the TU 507. The stock is on the TU. Okay, and it's going into the staging bin. Okay, give me a minute. Let me open the monitor. And while we are creating and confirming the tasks, we let us check in monitor. So what are we going to learn here? We are going to learn two important things as compared to outbound. One, we are going to learn LOSC, and the other thing what we are going to learn is the deconsolidation process. Deconsolidation is slightly different than the packing process because it generates waiting task. Okay, standard SAP process generates a generate waiting task. So as of now, we have seen opens task, confirm task. We have seen cancel task. Now let us see the tasks which are in waiting status. So here now, for unloading, we'll create a task. Okay, this task is be automatically created as soon as you move to the door. Okay, and the person who is supposed to receive would go here. 7. inbound, unloading, unloading by TU, delivery, ASN, door, whatever we want, we can enter. I think it's DR I3, and then it is telling me which pallet you're taking out from the truck. So I'll say I want to take out pallet, this one, 807. That's the only pallet in the truck. It's telling me to put it into the staging area. So I scan the staging area bin and job done. Okay. So now if you go back to your delivery, you'll observe one thing: good receipt is automatically posted, unloading is completed. So we have a separate transaction for good receipt. So why I did not do that? To show you there is this option where you can directly unload and automatically GR would get posted because system recognizes, hey, you're getting the handling unit into the warehouse. Or you can do good receipt of each handling unit and then do the unloading. It's up to you how you define the process. But SAP recommends you directly do unloading and the good receipt for that pallet will be done in the background. Okay. So in a faster moving complex warehouse, people don't generally open the pallet and at this stage during put away, they just check the labels and all, and they say okay, it's fine, so let us put it away, let us unload it. So the other reason for not spending too much time, because as I explained you, the time is very critical. Doors may be blocking the truck may be blocking the doors for too long, and it may um, result in less trucks getting unloaded, so unloaded or loaded from the door. So you try to reduce the time. So we did the unloading, the receipt got auto posted, and we can now go and check in the monitor. System has created further task. Since if you remember in storage control we have maintained a config, after you complete unloading the next task should be automatically created. So that has created 3 more tasks. Okay, so just make a note of the status here. Okay, so this is the only difference as compared to how we look at the task in outbound. Here only the task status B is waiting. Okay, and here you can see this task is open. So this task is to take the stock okay, let me open this way. This task is to take the pallet to the deconsolidation area. Okay, now what has happened, I'll tell you. Technically what happens in the system, see, when we do the unloading, system tries to determine a put away task. So now if there is these two products, they are going into two different bins. One is going into 8001, the other one is going to 8002. So system tries to create a task and then system checks, both the products are part of the same palette, and system has to perform deconsolidation. So deconsolidation is relevant in this case. If at all there was no requirement, if at all I just bring one product, okay, if I just bring one product into the warehouse, then this deconsolidation will not be applicable after unloading. Directly, it will try to put away. Okay, so this deconsolidation step was generated because system has to first try and check where the product has to be placed, and then system will recognize, okay, yes, they are getting splitted. The handling it has to be splitted. That means you have to repack. Let's take it to deconsolidation work center. So if it is one product, it will not propose you for deconsolidation step. And while system has to check where it will go, so it is temporarily blocking this bin because see the situation can change. Now 800, these two bins are available, but once I do the deconsolidation, you know those two bins may not be available. So deconsolidation may be the after deconsolidation the products may not be able to put away because somebody might have you taken those bins. So system temporarily allocates this bins to this product so that the next these products are going to be unpacked and they're going to come to the bin. So no other products or no other pallet should be placed into those bins. Okay, that is the reason system creates a waiting task. Okay, so it is waiting for deconsolidation to be completed. So now let us move this pallet to the deconsolidation area. Let me put the handling unit number. It's not a put away task. It's an internal warehouse movement. So I'll go manual selection. Selection HU. Suitable warehouse order. Oh, this is suitable warehouse order not found because what queue it is assigned to. Okay, it's assigned to inbound queue. I remember. Hmm, let me check my resource. So I'm using forklift to RGR2. Let me assign the inbound queue to RGR2. Okay, so if I now try to look for the stars, so now system is telling me to take the stock from the staging area. Go to staging area, scan the staging area, scan the HU, and then I'll scan the deconsolidation bin. Okay, that's it. Task is confirmed. Let's go back to the monitor. We have to go back to the monitor every now and then to check the task how they are getting confirmed. Okay, so now you can see this task for deconsolidation has been confirmed. Okay, but system has these two tasks are still in waiting because it's waiting because deconsolidation has not been completed. Okay, so let's go and complete the deconsolidation. So for deconsolidation, that is repacking or splitting these pallets, there is a separate transaction for deconsolidation, which is similar to a work center transaction that we saw in outbound. DCONS. Okay, we use a CWM pack transaction, but now we're using DCONS deconsolidation transaction, and the work center we are using is DK. Okay, so here you can see this is the pallet, and you can see it is assigned to. So pallets are assigned to process steps. It is assigned to step IB02, and you can see these two products, and they have waiting task assigned to them. So let me, pack them separately into Euro pallets, okay? I'll create two Euro pallets and remove them from the cart and pack them into pallets. So whenever we pack or generate new handling unit, we have to print the labels, okay? So if required, we'll select and print it from here. As of now, our PPF or printing related set, discussion has not happened. When we go through that, we will see how prints are initiated in EWM. Okay. So whenever you pack, please keep a note. You have to select the task and pack it. So whenever in packing, whenever you're doing packing, you have to select in the drop down, whatever is the lowest object. Okay. So I have drag drop the two um, tasks and pack them separately. But does it still mean deconsolidation is completed? No. For completing deconsolidation, we need to complete the step. So I'm completing the step here. Now system knows that deconsolidation is completed. I will complete the step here. Okay. Save it. You can say system has created another task in this case. There were already two tasks, but system has generated another task. Okay. What is this task? What is happening? Let us look into the monitor. Okay. So I'm going to refresh it. You can see now there are so many tasks created. Okay. So first we look at this task. This is for the Euro palette which is supposed to go to 8002. So one of the product which is supposed to go to 8002, it is unpacked. We got a handling unit. We can just say confirm in foreground and confirm it. Okay, I'm not using RF here. So now this is done. So so we got two products packed into carton. We separated them into Euro pallets. One of the one which is supposed to go to 8002 it has gone. But the one which is supposed to go to 8001 cannot go directly because we have activated a LOSC step. Okay. So now I would come here. Into Horus monitor and have a look at the task. So you can see here there are two tasks based on the status. There are two tasks which are pending now. C means confirmed. Okay. So only this task is open. This is again waiting. Excuse me. So what is happening here, if you observe carefully, system has created a task to go from deconsolidation area to the intermediate area. Okay, but system has also created another task, intermediate task, waiting task to go to 8001 final bin. So what has happened here? System tried to create a task to 8001. At that time, system recognized that hey, we have to take it via intermediate area. Okay, so in the intermediate area, system created a task, but this task system kept it open so that the bin should remain allocated to this product. Otherwise, because the C system has already determined a bin, again they have to determine the bin, redetermine the bin, and there are chances that the bin may not get determined, then the put away task will fail, and then the pallets may accumulate in the staging area, in the intermediate area. So it's better to lock that bin by creating a waiting task. Allocate that bin by creating a waiting task. So here you can see we will now move to intermediate area. I'm confirming it in foreground so that you can see all the uh, data for the warehouse task. Okay, like from where to where it is going. The pallet, the Euro pallet 66 is going from deco to intermediate area, the LOSC step. And you can see it's part of put away and the activity area process type. You can see all other information here. Okay. So as soon as I move it to intermediate area, I refresh, or I do need to refresh, you can see the previous task is now open. That task will take the stock from intermediate area to the final bin. See, this is the difference between POSC and LOSC. In POSC, whenever you go to deconsolidation or you go for repacking, you have to do some packing and say, step completed. Whereas in LOSC, as soon as I moved, system created next task. I don't have to do any packing or I don't have to complete any step because the layout is just, a layout constraint. We are just taking via that storage type. We're not going to perform anything. Okay. So here we just took it to intermediate. Now from intermediate, let's say till intermediate, a forklift took the task and now a VNA truck would take it from intermediate and put it into the final bin. And they will do it by performing confirm plus save. And if you now refresh your delivery, you can see the goods receipt, put away, unloading, everything is completed. But for our delivery, for our TU, it is empty now. We can load more products into it, or we do yard movements and take it to checkpoint and check it out. We will send the empty truck out of the yard. Okay, so the checkpoint. Now we'll say departure plus save. The gate person says departure plus save. The status gets changed to completed, and now the process has completed from a yard perspective as well, TU perspective as well. Okay, so this is how we execute storage control for inbound process. Okay, so any questions on storage control, whatever you discussed, inbound, outbound, anything anybody would like to discuss?
No, Ron. Still, we are behind your classes as of right now. So I'm behind your classes. So
Mhm. But we got the conceptual understanding of what
yes,
the
yes, yes, Ron.
purpose and how we are trying to achieve it. Yeah? Okay, that is good. So, shall we move to the next topic then? If no questions on storage control.
Yes, from my side, Ron.
Okay, right. Uh, Now, think I take that as yes from others as well. Hmm. Now, where are we? I think we wanted to discuss production, right? Production processes. So let us now talk about production process, which is part of Unit 5. We parked the production process because we were at a very crucial stage where we were discussing the um, process, waves, then creation rule, and then we thought, let's continue with storage control and complete the entire complex process for outbound. And then we, since we're talking about storage control, it makes sense to also go through the storage control for inbound. Okay. Now we go back and see how EWM integrates with production. Okay. So production integration, how we supply parts of production and how we receive parts from production. Okay. So there are two types of solution you can choose here. Okay. So when we integrate with production, we need to understand certain production related terminologies and master datas. I'll try to cover it very high level, and focus more on EWM. But you know, um, if you're new to these master datas, yeah, you can explore more offline and maybe try creating them in our system. Okay, so production, when we do MM or SD, we create a sale order or a production order or a purchase order. It is pretty much straightforward. But when we create a production order, we have to do a lot of 2-3 master datas. So let's go through them as well. So this production integration talks about, if a very high level, we know that the sale order, we have an order in the sales, we process it from the warehouse, issue the parts. In case of inbound, we have order from purchasing, we receive the parts into the warehouse. In production, it's both inbound as well as outbound. There is production order against which we supply parts to production, and then there is uh, finished goods which we receive from production and we put it into the warehouse. Okay, so we have both outbound as well as inbound. So that's why we take it at the end, so that let's you have idea of about the strategies and process types, because the same concepts are going to be used here. Okay. But we'll be using these or against production orders. So now the production team makes production orders against which they have some material requirement on the production line, and then they'll use that material, they'll consume the parts, and then they finally, at the end of the production line, they will receive the parts. So I'm talking about discrete manufacturing. There are process manufacturing, repetitive manufacturing also, but our focus would be on discrete manufacturing, because this product pump, which is for a specific industry, is a discrete manufacturing process. Okay, so in in case of when you go into a project, you will be discussing with your production team how to send the parts to production, how to consume them, and how to receive the finished pallets. Okay, so in case of production integration, we have two types of solution. One is PMR based and one is delivery based. So delivery based is kind of a old solution of SAP. I would not say old. I mean, SAP started in EWM with delivery based production integration, and then the PMR was later added. And I'll give you a background why it was later added, what were the benefits. So we have basically, the production orders. Okay. So if I tell you about production high level, there are 3-4 steps. Production order is created, then production order is released, then staging, where staging tasks are created from warehouse. Then obviously staging tasks will be confirmed. Then the consumptions are posted. so that whatever parts have been supplied, they are consumed in the production. So it will post 261 movement type in ERP for the production order. I would also say staging task confirmed. That will staging means we are sending the parts to the production. Okay, and then we do the post good receipt for the finished product, and then we do the put away, which will complete the process. And when we do the post good receipt, 101 is movement type is posted in ERP. So this is the high level process, and then this process is delivery based. This process is based out of ERP. Okay, like most all the processes are based out of ERP. Obviously, task confirmation will be EWM. Consumption posting is, and when I say ERP, that means they are initiated in ERP. Okay, put away and staging task confirmation are executed in EWM. So in delivery based, what I would say the master system is ERP. ERP takes a staging, creates a staging task. ERP does the good receipt posting, and EWM, like when we say staging task is created, here in this case outbound delivery is created. So as soon as we release it, outbound delivery is created, ERP and EWM, and against that we do the picking and then complete the outbound step. And the moment the good receipt is posted, it creates an inbound delivery in the EWM side, and we do the good receipt and put away. Okay. So I would say inbound delivery is created first here. We had this process, created this delivery based scenario, and I did implement for several companies when initially in EWM we don't had any other option. We just had this this process delivery based. It's still there. So the benefits, and there is one benefit, but there are many drawbacks. If you see here in this entire process, the master system is ERP. Okay, so production order ERP is created, no problem. Orders is in ERP, no problem. But outbound delivery or the staging is initiated from ERP. Okay, so sorry, let me put it this way. The outbound delivery is created from ERP, and which creates outbound delivery in EWM, and then in EWM the task is created for the delivery. Outbound delivery, like we do in outbound delivery task creation for a sale order outbound delivery. Okay, so here every even consumption posting, it creates an outbound delivery and creates a outbound delivery in EWM, and automatically the stock is consumed. So this outbound delivery is basically to take the stock from one store location to another, or it is an internal warehouse delivery to take the stock from one storage type to another, and then using this outbound delivery the stock gets consumed at the production. And then when they post GR again using MyGo or any transaction or through their confirmation process, it again creates a inbound delivery, and it goes to EWM, and then EWM has to do the good receipt and put away. So here there is too much control on ERP, too much in I would say uh, too much dependency on ERP. So EWM can directly talk to production. Okay, so like uh, what we do basically, we try to eliminate the deliveries here. Okay, so why we need to eliminate the deliveries? So on using this delivery based solution, what we realize that the deliveries are created. Let's say staging. Now staging is to take the stock from warehouse to the production area. That means to take the stock from here to here. Now warehouse, the stock is in warehouse, is in storage type. Warehouse has more exact information about stock. Why we need to create a delivery? We can directly create a task. See, you have seen the outbound deliveries, inbound deliveries. There is such a massive document with so much information. Yeah. Let's say your ERP EWM is down. Your deliveries will not come to EWM. EWM will not be able to stage. So there is too much dependency on delivery. It's a major big document, and there is dependency on ERP WM integration. Let's say every if a manufacturing facility is making any product every 30 seconds or a minute, they can't sustain such high this integration, delivery-based integration cannot sustain such a high volume. Okay, then SAP said, okay, let us remove delivery and let us find a different way to direct set up communication, direct or I would say let us uh, pass on all these activities to EWM so that EWM does the staging, EWM does the consumption, EWM does the good receipt, and tells ERP that we have completed that. Okay, so the master system becomes EWM. So EWM is going to execute all the three steps, and it is going to update ERP once they are completed. So PMR was introduced in I think 9.3 version, and basically for high volume and um, um, warehouse faster. I mean the manufacturing facility with and faster lead time, the product receipt lead times. This was the PMR was very useful. So here now we have PMR. Okay, in PMR the steps are, I'll explain you how the steps would be. So we create production order, we release the production order. So we don't create delivery. So as soon as the PMR production order is created, the production order is sent to EWM. Like a delivery, we have delivery in ERP, replica of ERP delivery. Same way, a PMR document is created, which is nothing but a replica of your production order. Okay, and it has minimum production order information which is required for the execution. Okay, so here a PMR document gets created. So against the PMR, we create a staging. Against the staging task, we confirm. Then consumption posting. Now EWM has the production order information. Now on the scanner itself, they enter they know which component are required, what is the finished product and their quantities, because they are now not referring the production order or the delivery, they are referring the PMR. So EWM knows like what components have to be posted. So we can directly post consumption from EWM and it will post a consumption in ERP. So the process steps are initiated in EWM now. Okay. So then we also, in terms of inbound receiving also, you can create a post good receipt, but it's not created in EWM. Inbound delivery is created, but it's created in EWM, and post good receipt is also posted in EWM. So every process, okay, once the production order is created, it is sent to EWM, and there onwards everything is done in EWM. So here in this case, you will see that there is no dependency between ERP EWM communication. See, in a decentralized warehouse, it's a very big thing, communication between one ERP to another, from the ECC to EWM. It can stop or it can slow down, at sometimes, depending on, how your server and volumes are. So here, if you see in the PMR based, ERP or ECC is sending the production order to EWM and saying, hey, this is yours. do whatever you want to do. Just update me what you've done, what step once you've completed steps. So EWM is just executing everything in the as ERP or ECC becomes the backend system. It does goods consumption post 260, it will post in the background 260 into ERP. It does receipt in the background, it will do 10 into ERP. And then obviously there will be staging to take the stock from warehouse to the production, and then so on. We will try to do the um, we'll try to complete the entire process with more more importantly the task getting initiated from EWM. Okay, or the process getting initiated from EWM, or controls are more at EWM level. So this was not easy because it requires some master data, like from master data from ERP we had to move it to EWM, and there are many more things we'll see which are required for PMR. So we will be focusing more on the PMR based integration because that's what is used because of these benefits. You'll see PMR at most of the companies, but the delivery based also is used where the volumes are not big, embedded system, no dependency on the between ERP and EWM because now we have a embedded system. So the other reason for using is let's say if we are using a embedded EWM, so then there is less issue because it's the same system where the RFC communications are going between ERP and EWM. So people prefer this in those scenarios. Then prefer this. Again, there'll still be a counter why we need to create a big document like a delivery. In a year, we don't create delivery, we directly create the task. Okay, so less data footprint. Then the other possible reason, other challenging reason where people may still you may see still some warehouses going for um, delivery based integration is because of waves. Okay, so wave is very important. Companies like it. You have seen the timing aspect, the grouping aspect, and how the pallets are merged. So wave is very important. Since we have deliveries, we have waves. So SAP basically did not eliminate delivery based. It's still there. We can still use it. So some companies, they have warehouse very far from, you know, the production line. Let's say not in terms of miles, but it's not direct attached. There's no one wall. You have to do um, some, you have to drive a few yards more and deliver the parcel production. So sometimes it's a different building in the same campus. So for those purpose, you have to group as many items as possible, prepare pallets, and then send it to production, and then there are empty pallets coming from there. So companies, prefer waves, and waves is not possible here. There similar wave kind of functionality we'll try to achieve through staging when the task are staged through batch job, but but the wave kind of grouping, okay, those grouping of tasks is not there here. Okay, so the companies, if they prefer wave management, then they will go for delivery based. But before we go for wave management, when I'm going for project, I'll try to explore as much as possible how I can group the staging tasks using PMR, or something like a wave I can give them in the PMR through some enhancement. Okay, so wave is a challenging point, where I mean important point where we have to challenge and discuss which integration method we have to use. So the preference is always PMR, and the only thing is what functionality we have in waves. We need to see how we can achieve it through the batch job for staging task creation. Okay, so we'll see that where we are executing the process and each step in system. But This is high level explanation about what are different possible integration that we can have with production. Okay, so now um, we know now, like, we are going to go with PMR based, and these are the steps. Now what we will do, we'll first discuss the master data. So this process requires master data on the ERP and EWM side. Okay, so most of the configuration here is your strategies, you're picking strategies, good put away strategies. So we have already done that. So you will not spend much time on that. It's just the same thing, just the process types are different. So let's focus on setting up the master data and executing an entire process with all these steps. Okay, so there are several master datas in this process on ERP side and EWM side. Let us list them first, yeah. And we'll try to understand what they are. So first we'll discuss the ERP master data. So all ERP master data have to be done by production planning team, yeah. So this the master data are routings where we list what are the steps which we are going to perform in a production order, bill of material where we give information about which item in which step. So for example, when I make a car engine, there are two steps where I do the cranks, block, crank, and shaft. I prepare them through machining, and then I take them to another sub-assembly area, another side of the warehouse, another side of the production facility where I'm assembling this with the other components. Okay, so your production order can have your production order can have several steps as part of production, so that those are part of routing. So in the routing you will have list of all the uh, work centers and what production operations are being performed. Okay, so in the production line also there'll be different areas, sub assembly areas where the production will be taking happening. Like first area would be assembling of the pump, turbo drive with the casing. The other would be shaft assembly. The third would be like the wiring, the other settings. So other fitments. So the production process is divided into several steps, which you'll find it in routing. And for each of the steps, what material you need. Okay, so BOM is list of all the materials that you need for the production process. Then we have something called as PSA, control cycle. I'll explain what is control cycle. And in EWM, we have master data called as is done by us is PSA to bin assignment. PSA bin assignment. So when I say, when we talk about the production process, we have staging. Okay, we have c- consumption. High level, these are three steps, and then we have good receipt. Yeah. Okay. So when we do staging, there are different types of staging. We have single order staging, cross order staging. We have credit part staging. And then in case of consumption, what we have is, we can either do a consumption. So when the parts are in the production area, you can either consume them, okay, which we call them as manual consumption. You just say I will consume this part, but it will not be possible to always declare that manual consumption. Like, if in a basically for pump there are around 25 to 26 components. So if a nut bolt washer is consumed, they don't need to tell system scan and say, hey, one nut bolt used, one washer used, one gasket used. These are small consumables. Yeah. So what we do is something called as backflush. So as soon as we complete the production process, you know we have something called as confirmation step, where system will do a backflush and consume the parts automatically. So manually you don't have to say how much has been consumed. Okay. So some parts in your bill of material will be backflush parts. So these are the possible variants I'm discussing here. Then in terms of good receipt, I don't think there are variants. It's just good receipt on the RF and do the put away. But yeah, we'll see if something else comes up while we are discussing and looking into the system. So here the important point is the must we are talking about the master data. Okay. So what is PSA and control cycle? So PSA is basically in the production line. When you look at the production line, this is your assembly hall. The production lines go something like this. It will be just one straight line, or if it's a bigger operation, it will go like this. Oops. The line would go like this. Something like this, yeah. So the components, first they are fitted, and the semi-finished parts will go from one location to another. It will keep on moving, and then finally here we have something called as end of line or end of production area, where you receive a finished product, you pack them and do the good receipt and put away. So this is start of the line, this is end of the line, and here we do the receipt and put away. Here we'll have inbound staging area. We I haven't created a separate storage type. It is separate, similar to 9010. In standard system it is Y995. Let us use that. And then we do the put away into the warehouse. Okay. So when we supply parts from the warehouse, let's say you're bringing stock from 8005, for example. Okay. When we are bringing stock from the warehouse, then in that case, if the part is required here, there is no point in supplying here, right? So if the part is required here, just imagine big assembly lines in case of a car, in car manufacturing, the lines are really big. Yeah. So here, if we need the parts, I would rather supply here than anywhere else, right? So what we do is, and let's say the part is required here, I may, supply somewhere here in middle of these areas, so that the metal can be, this guy can also go and take the metal from here. This guy can also go and take the metal from here. So we can place in between two point fitment areas. Yeah. So first the casing comes, it goes, moves ahead, components are getting attached to it, and then finally we get the final casing, final pump. So what we need to discuss based on the physical layout of the floor, plant floor, where the materials have to be supplied. Okay, so it can be, so these are basically, there are production work centers. Okay, like we have work center, we are performing packing. Similarly, there are production work center where where they do some assembly or any specific activity. So here you can say supply parts here, supply part here, supply part here, supply part here. For each, you know, so each movement, like from here to here, I can say there is one drop point here, there's one drop point here, there's one drop point here, there's one here, there's one here. So I can create several bins. I have to create, my aim is to create several bins and tell the system that, hey, send the parts to these bins. Okay. So, but when I supply parts to the bins, I can also create multiple bins. Okay. Let's say I can say this is one supply area, one entire supply area, which is a casing assembly, for example. And here I just have one area, and then I can create one PSA here, PSA production supply area 1. This middle subassembly is, oops, this middle subassembly is where, it's another area, supply area 2. Okay. So, and then there is a third supply area here, 3. I can have 2 or 3 supply areas. It can be even more. See, you have several assembly halls. So, entire hall can be one area. Okay. And then here, what I say is, if a product is going to supply area 1, this is bin 1, PSA.01.01, supply to PSA bin 1. If in this supply area product B is going to, has to be supplied here, then supply it into bin 2. So each supply area can have several bins. Okay, and now here in this master data, we say how many supply areas. I mean, we will not say, the production team has to say and create them, and then we tell them, okay, we have so many supply areas. Then you give us which bin a particular part is to be assigned. So we say a part in the supply area should go to this bin, because in the supply area it can be multiple bins. Supply area, we can create one supply area for the whole production itself, production line itself. But what we are interested in, which bin we have to supply that part. Okay. So this is PSA bin assignment to product, which PSA, which bin we need to supply. Then control cycle is basically, that's where we say it's a delivery based or a PMR based. So when I show you in system, I'll show you, there is an indicator, staging type or something, where we say, whether it's a delivery based, then we give the staging types there. If it is PMR based, then we say staging method is 5, that means EWM staging, and that means it's basically a PMR based process. Okay. So those who have also already worked into this process in the ECC or non-EWM system, the processes, you might be well aware of these master data. Same master data are used, but they are now extended to EWM and to integrate with EWM. Okay, so this is how we are going to test the production process. So any questions, guys, on the production process before we look into the system? Anything you would like to discuss? Are we good with the production concept?
Yes, Ron.
Can we take a 10 minutes break? Come back around 1 and continue with
Okay.
the system execution? Yeah.
Sure, Ron.
Okay, then I'll be back in 10 minutes. Thank you. Hello,
Yes, Ron.
shall we start? Sorry, I got a phone call. It took some more time.
No, no, no
Shall we
problem.
start
Problem.
with the execution?
Yes, Ron.
Okay, okay. So I was just wondering. I did not explain one more concept. So this is. We spoke about backflush and manual consumption, but we also have different types of staging. One is single order staging, where we send parts to the production area per order, and these are like important critical items. Like for a car, it would be the engine. For for pump, it is the turbo drive. It may have its own serial numbers, and one unit, like one or two units, we supply specific to a particular vehicle or a particular finished product. So single order is specific to that order. We supply parts to the production. Cross order is where we group parts for multiple. We group parts for multiple outbound, multiple production orders. We send it to production. So these are very critical, important parts. I would say these are semi-important kind of things where the same part is going to be used in all the finished products. So rather than supplying for each production order, let's say 10 piece for order one, 10 piece for order two, we just supply the entire quantity, 100 maybe for 10 orders. Or let's say a system will check what are the total order due. It will group all the requirement and create one task to send it to the production area. Okay, so this is a cross order. So when in this supply area, today there are 10 production orders or 20 production orders scheduled. So when I'm sending from my warehouse, I will just send all 20 pieces or 40 pieces, whatever is the requirement for 20 orders, in one go to this area. In case of single order, I would supply, there'll be separate task. you know I would supply one piece now, and then when the production order goes for the next production order, I'll supply a separate piece. So one by one, I would supply this critical important parts. So crate parts is the, I would say, the very less important. Importance means compared to the other parts, not that critical. So these parts are something like nut bolt washers, which I explained you for backflush. So we may not, supply those parts to all the BSA. What we may do is we may just create a bin here. Okay, we take a big box of bolts and keep it here, or at two three places. The team will come and pick it from here whenever they need it. So crate part is you just make sure that there is one pallet at the production area for that item. One pallet can have 10,000 or even more than that bolts. They just go and keep it there, the crate parts, and the production uses them as and when they need. These are less important parts, and you know um, crate part basically, you know we don't. It's even though it's crate, it's kind of a replenishment. It's not linked to the production process. If a production order is not there, which needs that material, still we'll make sure we'll go and supply that part to production. Okay, so the parts we need to supply to production, and for the crate part, it's not linked to any production order. So today, we will discuss crate part as part of replenishment, because that is based on minimum maximum level in the production area, and these two are based on production orders. Where the stock goes down, we get, when the production order is scheduled, we get a single order to the PSA, and cross order we group all the orders and bring them to the production area. Crate part is like, not, even though you may find it in the BOM and you may find it in the PSA, in the PMR, and in the production order, crate part, the supply to production, and even though you may consume it, but the supply is always irrespective of the production order. It will just check, hey, one pallet is there, no, get one pallet, just keep it there. These parts are used throughout the day and for multiple orders. Some may use it, some may not use it, but the supply is made sure it's always available there, okay, for consumption. So we are going to see, single and cross order part today. Create part we'll see as part of replenishment, because we need to maintain min max levels, and we need to see uh, we need to understand few concepts about replenishment, which we'll discuss in the next session. Okay. So let me log in again, and let's execute one production scenario. Okay. Right. So what I have done is I have created one production order with help of my production team. So I will just take you through the order and the master data. You can copy the same and create for your plant. So this is the production order 284. Let us look into that, and maybe let us copy it. Yeah. CO01 is the transaction for creating production orders, and I will copy from an existing order 35. Okay, so let's say here I am saying I need 40 pieces, and okay, I'll just keep 4 pieces. I'm not sure whether I have enough components or not. So here I would say, when is this production going to end? So I'll say the production ends 23rd. So it will do a, oh, not 2. I need to do a, oh, it's in future. Okay, let me say 14th. Yeah. So it does scheduling, and it tells us by when it should start and so on. So there is something called as backward scheduling, forward scheduling in production. So it does this scheduling and find out when it should start, by when the material should be there in the production and so on. So I've just put a date, by when this production is going to end. I need, let's say, one pallet of pump. I need it in store location. Let's say, receive it in 4,000 maybe. Yeah. And if you see here, I've kept, just for understanding purpose, I have just kept two products. Our bill of material has 8 to 10 products. I've just kept two products. One of them I've kept it as single order. The other one I have kept it as cross order. And here you can see the store location is 2000, from where I'm going to supply the part. Okay. And then in terms of routing, I've just kept one operation that we are going to perform assembly. In this operation, we are going to assemble a pump. Okay. So this production order is for one complete assembly of pump. Okay. And we are going to do it at one work center, and everything we are going to supply to that work center. So I've just kept it simple, but you can elaborate this, create multiple um, products and multiple staging areas, and so on. Okay. Hmm, okay. Now let's try to understand more about the master data. Okay. So what were the master data required? First, we have the bill of material. Okay. Now bill of material, you will not own it, the production team will own it, but I just want to make sure you are aware of certain fields. So here, for making one pump, I need one bolt and two slugs. So here I've just, it's 4. Our requirement is 4. The quantity has increased, proportionately. And then here I have given that this component you supply to this PSA, okay, in the bill of material itself. Or, I can give the PSA in the, at one more place I'll explain you. But here I'm saying, this product will be picked from 1000, and this is where it has to be supplied. Okay. Same thing if I've maintained for the other product as well. I've just said it's going to the same PSA, and 2000 store location. If it was a backflush part, you would see a backflush indicator here. Oh, not here. You would see it in a production order. If it would have backflash material, you can. This backflash can come from material master, or you can also set it up. Okay. So, so this is the bill of material. Then this is the routing where we list all the operation. So in this we have work center. You can also give your PSA for the work center. That means the production operation is getting performed in this work center. So I need production. This is my PSA for the work center. So the business can create separate work centers. Like especially in case of machining, the whole machine, it's very big. You can imagine a very big machine. Um, uh, like we have this. If you see machining process, for machining there are very big machines, and there is space, near to like this is drilling and mm, like such machines are there. But now we have such machines which are very big. Okay, and there's operator here, and next to them, there'll be a place marked. What is the component for that machine. So nowadays, these machines, and they don't look like this. They are fully automated and integrated with all the sensors and computer enabled, and you just fit your program, and accordingly the product goes in, machining happens, and it comes out. Okay, so this kind of machines, you will see mostly. Yeah, just I'll try to enlarge the picture. Yeah, such kind of machines you will see where the person sits here, does does type in whatever is required, and then materials are fed from here and taken from the other side. This is very common machining process. Okay, so this may be a work center, and they may in that work center, they can say this is the PSA for the work center. So either you give it to the component if it is component wise supply to a certain PSA, or you give it to the operation, the assembly, the sorry, the work center, the PSA information where the material has to be supplied. I'm saying the PSA is in my bill of material. So this material supply here, that material supply there. Okay. Then just routing. Then probably we also need to another master data which is required is in the material master. We need to make sure the um, work scheduling view is maintained. In the work scheduling view, you need to make sure that the production version is maintained, and it has these two. When you maintain the production version, just click on check, these two should become green. Okay, that means it will get determined in the what routing you're using and which bomb you're going to use. We give that information here. Okay, so this was all master data which the production team is going to do, um, and they will do some more master data like creation of PSA. So you saw me using PSA 001. So where was it created? It's created in PK05. So here you can create PSAs. So in decentralized EWM, once a PSA was created, it had to be replicated to EWM. In embedded, you don't need to do anything. Okay, so just PSA gets created automatically. EWM will also recognize that PSA. So here 2000 is the production store location. Just kept it as 2000 for our testing, and this is the second PSA. So I've created two PSAs. Okay, now where do we say that it is a delivery based or a PMR based integration? We do that in the control cycle. Okay, I'll maintain control cycle generic. I'll not maintain it for a product. Control cycle, if you don't maintain for a product, it is applicable for all your finished products. So anything which is getting supplied to PSA001, I'm saying here the staging indicator will be 5. That means EWM staging. See, if at all I'm not staging in EWM, then I can select the staging, whether it's a pick part, create part, release order part. These are the similar to single order, cross order staging. These are the staging process type of staging on the ERP side. Okay, so I've kept it as my EWM staging, and I have saved it. That all this, whatever staging has to be done, cross process, single order, cross order, or create part, EWM will decide. Okay, then so we created we spoke about BOM, we spoke about routing, we spoke about PSA control cycle. Now let's see. So we know a material has to be supplied on a PSA, but which bin in the PSA? So there is a very important master data which is PSA stage. See this master data you can also, I mean I'm used to using PSA stage, but you can also display the master data from LPK to, yeah, you can just go from here and open the data, but I'm mostly used to opening it in a separate transaction. Okay, so it'll open this. So here we say whether the product T-T100, where I'm saying it's a cross process or it's a single order, cross order or single order. So here the product, I'm saying it goes to this bin in the production area, this PSA. Okay, so PSA, whenever it gets replicated to EWM, you create a PSA, EWM will create it with the plant suffix. So the reason is EWM can communicate to multiple ERPs. I mean, it can also be used decentralized. So you also see the plant code so that you can identify for which plant this supply area is. So same code can be used by several plants, isn't it? PSA001 can also be used by another plant in the same ERP system. So we do that with the plant. SAP standard SAP itself does that with PSA001 slash PL35 plant code. Yeah. So this is single order staging. I'd say I need to replenish one quantity at a time. These are the process types, which are required, 220 and 325. So 320 is to supply to production, and if something is left over in production, if you want to clear that area, we bring it back to the warehouse. We use 325 moment type. Okay. Similarly here, we I've maintained cross order staging for the other part, and I've just said, minimum quantity is one. If the stock goes down below minimum, you supply parts in multiples of a replenishment quantity. Just kept it simple for our testing, and you can change these indicators and see how it impacts your staging proposal. Okay, so basically this is how replenishment quantity is how we round it. So I'll explain you in case of replenishment how this minimum quantity replenishment quantity are considered. For now, just understand, this is what we need for production, and here we identify whether it's a single order or a cross order part. Okay, so these are the master data involved in the process. I would save this production order now. So there is some costing done in the production process. In this test system, we couldn't fix the costing errors. So even if it gives you some accounting error, just ignore it. Okay. So a production order is created. We release the production order. Yeah. So we can start the process. So yeah, you can get some accounting errors. Just ignore them. So 286. So now as is released, it has to be replicated to EWM. It may not come because there is a setting in the production that staging should be automatic, but here that setting is not done. So I'm going to say manual stage it. Yeah, I'll say WM staging executed. So there is a setting in production where they say WM staging should be auto executed on release. It's not set up in the system, so I'm manually initiating the staging. Okay, now it should create a production order in EWM. So you can see it's a very it has less tabs, and in one document itself you get your components, your finished product, what quantities are required, and which PSA it will go. All this information you get it here related to production. So inbound delivery, outbound delivery are mostly inbound, outbound delivery, they are good, but for production SAP realized it's better to create our own separate document with minimum production related information. So you can see here the PSA, the type of staging, cross order, the process type came from there. This is the work center. This is the bin that we assigned in PSA stage. Okay, so you can see here this is single order and this is a cross order item. Okay, based on the setting that we did. Now we have to stage these components to the production. Okay, so now let's see how we can stage that. So there are three steps for a production order we need to execute. First, supply to production. Second, consume. Third, receive the finished product. Okay, so see there are why supply and consumption. So those who are new to to production processes, we supply to the production area. They may not consume it immediately. Okay, they may not attach it to the vehicle immediately or to the pump or to the engine immediately. They will, it will stay there, and you can see the stock is in production storage type, and then when you feed them, they should then consume it in the system either manually, or in case of backflows it will be automatic. Okay, in that time the stock gets reduced from the system. Okay, the first step staging is basically a warehouse movement from your 8001 2 3 4 5 to the production area. So when we do staging, now what config is required? So till here PMR, till you get a PMR, it's major rule from PP side. But when it comes to further settings, the next setting is when we create a staging task, system should pick from the warehouse, right? So we got a process type determined, we got a bin determined, almost the same thing what we have done in inbound, and outbound, same things you have to do it here. Okay, so but at a different place. So we have a process type which comes from PSA stage. PSA bin comes from that PSA stage master data. So now it's similar to a delivery. Now when we like how you create a task for a delivery, system is going to create a staging task. So how you maintain a strategy, like for 1010 movement type or process type, pick from so and so area. Similarly here for Y20 process type, pick from so and so area, put away into so and so area. You have to do all those strategies. Okay, I have set that strategy in advance because we have already covered them in detail for inbound and outbound. Okay, so now I would made a strategy that this part pick from here, pick from there, and this process type, this search sequence should be so and so. You can review that offline, for this warehouse. So what I'm going to do now is I'm going to do the staging. So we create warehouse task in outbound using wave. Here we are going to use a transaction called stage. Okay, you can run it in test mode also. Mm, and you can just simply execute it as well. Okay, so where is my monitor? Our production storage type is 1000. Okay, so this I've just created tasks for the old production order, the two production order which I tested with my production lead. So while I was testing, I created this task. So just I would like to show you. These are the existing tasks and new tasks will be created. Okay, or what I will do is I will cancel this task. Okay, let me cancel them. So just imagine we have three PMRs now, three production orders. Okay, and system is going to create tasks for the three. All of three of them are same. They have the same components. Quantities may be different here and there. Okay, but we have three PMRs. Okay, so what I'm saying, you can say, so we'll schedule a batch job and we'll say, whatever products which are required by 12, 1 o'clock, create a task for that. Then the next job run, whatever products are required by 12, you know, 14:35, create a staging task for them. So every hour we'll set up, depending on when the products are required in the production system will create a staging task. Okay. So here, I would just keep it in advance just to remove. I want all three of them to be grouped together so that I can show you how a cross order task is created. So I'm just giving a date in future, okay, just to exclude the date impact. So ideally this program will be run as batch job and you will have different time. So group, like how we were grouping wave, how we deliveries for waves, similarly all production orders will be grouped here. Okay, based on that, if their supply falls within that time slot bracket. Okay, I am going to execute it now. So system has created 4 tasks here. Let's go to the system and see. So here you can see why 320 is for single order. System has created separate tasks for each order. Okay, whereas 320 system has clubbed the entire quantity requirement and created one task. Okay, so you can see system is creating one task and this is for the entire PA production, entire all three of them. The point to note here is that with the cross order thing is is a cross order, so you don't see anything here, any production order assignment here because the it's picking for multiple orders. Cross order means across orders we are picking the parts and supplying to production, and these are all single items which we are supplying to production. Okay, and then for each task for each order. So basically in single order we are supplying part to production and it is reserved for that production order. Nobody else can take it. So if there are three parts, let's say there is another production order 26 which gets scheduled before these three, that production order 26 cannot pick items for these three production order which is scheduled for these three production order. Okay, then okay, now I think they need to slightly change the master data. So now here the bin is, you might have seen the bin. Let me take you to the bin. So this part, some of them are picked from 8001, some of them are picked from 8002, and they are going into this supply area. And let me open it in form view and then show you the bin. The products are going into this PSA bin. Okay. This one is going to PSA2 bin. This one is going to PSA1 bin. Okay, so single order parts are going to PSA1. cross order are going to PSA 2 bin. Okay. So now the only thing is the quantity is 1 for cross order, but we need, that's because I think I might have maintained here 1 in the PSA stage. Let me, for the cross order part, I'll say minimum quantity in PSA is 1. I don't say replenishment quantity, I'll keep it blank. Let me see how it goes. I want the entire quantity to be grouped, not one piece. For it is okay for these parts, but yeah, for this one I want the entire quantity to be grouped. Let's see if we can create a task for 12, yeah, 4 or 12, whatever is the quantity requirement. So PMR, what is my total quantity requirement for cross order part? It is 4. So 4 into 3. System should create a task for 12. I'm trying to achieve that, yeah. Let me create a task again. Did I cancel the task? Okay, let me restart the transaction. Oh, I'm so sorry. I think I might have confirmed the task by mistake rather than canceling them. Let me see if I have the stock here. I think my bad. I kind of confirmed them rather than canceling them. No worries. We can try that later. So basically, I was just hoping hexagonal nut. It should create 12 since this was maintained as PSA stage was maintained as 1. It created just for 1. So it's okay, we can try that later. But here, important point to note here is cross order part is not assigned to any production order, and but the single order parts are assigned to production order. They are reserved for that production order. Okay, because these are critical important parts. Okay, so just give me 1 minute. I'm going to try something in Master so that I can get more cross order parts in the production area. Mhm. This is cross order parts. I will say I don't remove this also. Quantity based calculation. Let me try if it helps. No, I would say no quantity based calculation. Okay, just take whatever is there in the orders. Still no. Say show log. So close order staging, but it is just creating one task. Don't want. Okay, leave it to me. I'll see why it is not creating. Maybe we need to maintain these indicators more appropriately. We'll come back to this during replenishment. So here, for now, let's see, we have stock here, single order and cross order stock. Now it's time to consume the stock. Okay. So the consumption will again, will be initiated from EWM because, the stocks are in warehouse. It's more appropriate, rather than creating an outbound delivery consuming, we will directly consume it in EWM using PMR. Okay. So what I'm going to do now is go to RF. Okay. I'll go to outbound consumption by manufacturing order. I'll put the order number, which is there are three order numbers. I'll say I want to consume for this order, the one which we created. I'll consume from pin PSA1, PSA hash 001 dash 01. The system tells us, that this is the product there. Consume quantity, I'll say I want to consume one. So PSA1, it's only one quantity reserved for that order. If I try to consume two, it gives me error. Yeah, you can only consume one. So if you select this, if I refresh this, gone. Consumed against the production order. Let me also consume the other one. Then we will see what happened to the ERP posting. Okay, I'll say this is just one piece, so I'll rather scan the palette and can also scan the handling unit and consume the other quantity as other part of others as well. Okay. So we have consumed one piece for both single order and cross order. Now it would go in ERP and update the consumption posting, which is 261 moment time. Okay, it has not updated. Let me see if there has been some failure in the queues. What is the reason? Okay, posting period error. Let me sort it out. Zero to 22. Let me reprocess the queue. 03 now. Okay, we have a different error. I think it's OB52 error, I guess. Hmm. Okay, let me do one thing. It's saying to directly maintain this table. T001B slash OSM30. Let's maintain this. Okay. So for S, what it is saying? Posting over GL account. S account have S and GL account. Period 03 for fiscal year 22. Okay, so you can see this 2 period. I need to make it to maybe 12. Yeah. Okay, now this would go and post the posting in system. Oh god. Okay. There are some previous posting because of which one of the consumption failed. Never mind. We got a consumption. We can at least see for one of the item. Let's go to the production order now. Okay, so now let us see whether we can see 261 here. So you can see here 261 has been posted. This is the consumption movement type. Important point to note here, it got posted from EWM. There was no ERP initiation here. There was no delivery in case of consumption. This is one of the benefits for using PMR. Okay, EWM is the front end system and ERP becomes the back end. EWM does the postings, the staging, and just keeps on feeding what it did to the ERP system. Okay, so this is one more benefit. Then we spoke about goods production supply. We spoke about the consumption. Now it's time for doing the receipt. Receipt. So now, in case of receiving a production order, what we do is we go to RF. You can see good receiving by handling units, good received by production order. I'll enter the order. So here there is like we have work center, there is a standard work center. Let's take that, which is YP11, which is basically which will get us the stock into GR prod. Okay, so we don't have the GR prod bin created. So let me create the bin GR prod. So I explained you, we are going to receive the parts into our storage type by 915, similar to 9010. This is production receipt. I'm going to receive it in Y915. Okay. Every time I create the bin, I sort them. So now at this stage, we need to do the receipt. I would like to do one setting here, which is a PPF setting. I'll explain you about this setting when we discuss PPF. For now, I just want to automate the good receipt posting. So I'm going to do one setting here. So just park this setting. I'll explain you what we did here when we cover the background about PPF. Postcode receipt for manufacturing. Oh, I'm so sorry. I think that was correct. I selecting based on plant rather than warehouse. Sheet from production. WH34. Let me maintain this condition. It's like an output control, like we output condition we maintain. This will initiate some PPF actions, automated actions to create a put away task automatically for production. I just want to show you the entire process on RF. That's why I'm maintaining this. Okay, save it. We'll come back to this condition record next week maybe. So now it's time to do the good receipt posting. Okay, I enter the production order here 284. Next week good receipt found. Let us say production order. Let us check. Is it 286? I think 286 is the one which we are working with. Okay, so here that one is created correctly. We enter the finished product number, and here we receive how much quantity we want to receive. Okay, so I can receive, let's say, one piece, or I can change the quantity and receive 4 pieces. Yeah, one pallet completely, all 4 pieces together. I'll say HU create, and it will do the grid receipt of entire 4 by. So now what system would have done? System would have good receipted 4 pieces and packed it into a pallet. Okay, and at this point of time, there would be a printer at the end of the production where the printout of the label will come. User will take the printout, of the label, put it onto the pallet, scan it, and do the put away. Okay, so at this stage, what you will also see 101 would have been posted here for the delivery. Yeah, you can see 101 has been posted for 4 pieces. Yeah, so we have received the pallet, and now we need to know the HU number. So basically, what happens is when we do the receipt on RF, in the background, it creates an inbound delivery. So the PPF which I was setting, that is to automate the good receipt posting. So in the background, it created a handling unit and an inbound delivery. Inbound delivery has status Y because it was generated manually in EWM. Then now, as soon as it is created, system will do the good receipt and will create a put away task. Okay, so let us create a put away task here. May not find a bin because I think I did not maintain the put away strategy. Let me say put it into 8004. Warehouse order is created. So after good receipt, they would go and confirm the put away into the 8004. So initially we added stock into 8004 using 561 movement. This is the actual way we would get stock into our 8004 storage type. Okay, put away by HU, and we scanned on the bin, and we complete our finish process, our production receipt process. So important point in terms of the receiving is we do receiving on RF. If you want, I can again show you, and it will create a delivery here. So you can receive the pallets inbound, good receive, receiving by order. We enter the order here. Okay, now there is nothing left, nothing pending for this delivery. So let me show you for maybe another order where I know it's showing giving me that error because the store location is missing. So let me now show you again 285. Oops. You can go in here, scan in the product. It tells you the quantity. If you don't want to receive it into pallet and just one quantity you have to receive, just press enter. It will receive one piece. So you keep on pressing enter till you want to, receive the pallet. So this screen will be open in the production on a scanner, and they will, keep on receiving. The pallets are internally created. If you want to externally create a pallet, then you can scan the barcode of the pallet here. Okay, if there's a pre-labeled pallet, you can scan the barcode of the pallet. I'm just saying, for my warehouse process, I'm saying, okay, I don't want to receive one. I'll directly receive four, and then create HU internally, and then you can see another delivery would get created, and this HU is got created. Good receipt is auto completed because I have activated that setting which I was telling you, which will post good receipt automatically. So as soon as the receipt on the scanner, a delivery gets created in the background, and the post good receipt is automatically created, and put away task is also automatically created. So and system will try to put it into the final bin. The next step would be just take the printout, scan the barcode, and put it into the bin. So this is how we execute the Production integrated process was a bit of a lengthy process, but it's very important you especially understand the warehousing part. If it takes too much time for you, to set it up for your plant, maybe you can use this plant with PL35 and test one complete cycle. Okay, so I think we'll stop here for today. Any questions? Anything anybody would like to discuss? Are we clear with the production integration?
Yes, Ron. It's all good for now. Yeah.
Yeah, maybe once you see the entire process, by yourself, it will be more clear. Just the number of steps are more compared to inbound and outbound. So just try to execute it in this plant, and then you can slowly start setting up for your own plant as well.
Yes, Ron. Sure.
Okay. If no further questions, then shall we end the session for today? Tomorrow we will start the next topic. So we have completed storage control, and delivery integration. So we have to start internal warehouse process tomorrow. So tomorrow and maybe a session after that we'll discuss replenishment, stock transfer, posting changes within these and physical inventory. These are the processes 9 and 10 related to internal warehouse movements. Okay, so we will meet again then tomorrow and start with the internal warehouse process. Okay, see you tomorrow
Okay,
then.
Ron. Thank you.
Thank you. Thank you. Bye.